How y'all doing?
Good, thank you.
Good to see y'all, man. Good to see y'all. I'm glad y'all made it to the study session.
Recorded.
Nice try, bro. Nice try.
A little too late.
A little too late. You almost had an A right there, bro. You should have put an A. We got 4 beeps. So do you guys have any questions?
So me, Josh, and Danny were all studying for like 3 hours earlier today.
Woo!
And Josh,
Y'all didn't invite me?
What?
Y'all didn't invite me? How rude.
I know.
We just figured out. We like just
I'll
pulled
be
it
trying to
together
study
today.
with people, man.
So Josh wrote down the questions. It was mostly on 11.1, I think.
Okay, cool. Let's do it.
Them. Oh.
Do you want Josh to pull them up?
Yeah, because Josh wrote down more of the notes.
Hello. Okay, I'll pull them up.
Questions.
So, all right. So I'm gonna start with 11.1. To open my MyMathLab real quick. Almost there. All right. Okay, here you go. 11.1.
What you eating, Mario?
Some panda.
Woo! Oh man.
Yeah, got some some DoorDash.
Oh dang, bro. How come you didn't give me none?
Cause I thought you only like coffee.
Yeah, no, I like boba. What you talking about?
Oh, boba. There you go.
Okay. So 11.1. Oh man, it's not working. Stop share. Reshare.
Shay, where you at? Shay, we can't see you. Trying to be incognito?
No, I just had to like walk to my car to get some stuff.
Oh, okay. Ooh, look at that sky. Beautiful sky.
I want to ask
Come on,
something.
Okay, so 11.1. I'm gonna skip the first couple of questions. All right. So the first question we did is we went over this one, and so a way that, so I think our problem as a group is we were trying to figure out like where our weaknesses were, and one of them was trying to kind of remember the formulas and what problems they go with.
Right.
So for this one, for instance, Maggie came up with because the P is the proportion, so you would use 2 prop z-test, so 2 proportion z-test. That's kind of how we memorize that one.
Yeah.
But some questions that we had with this problem. The first one is the problem going to tell us what we're testing? So up here, for instance, it says test whether P1 is greater than P2. So on the test, when we are given this question, is that how it's going to be worded? Something, or how would it be?
This is not a question on the test. This has no context to it. So this question would not be on the test. It's not going to tell you test that. It'll say something like test whether or not more people from SMC smoke than people from West LA College.
Okay, so it's going to be something more like, I'm going to go to another question. So it's going to be something more like this, right?
Yeah.
And a random double, so it'll be something like this, so you'll know, like, basically, so group 1,
no, but look at does the. Last sentence, does the
evidence suggest that a higher proportion of subjects in group 1?
Higher proportion.
Okay, so group 1 is like your P1, group 2 is your P2, and then your alternative hypothesis is going to be greater than because it's asking for a higher proportion.
Yeah, but you have to make sure you define P2 to be the one that's greater than. So
Yes.
like higher proportion in group 1 experienced fever as a side effect than subjects in group 2. So then it would, so then group 1 would have to be P2, right? Or you can just say group 1 is P1 and then say P1 greater than P2, right?
Yeah.
That probably makes the most sense. P1 is from group 1, and so your alternative would be P1 is greater than P2, right?
P1 is greater than P2. Does the evidence suggest that the higher proportion of subjects in group 1 experienced a fever as a side effect than the subjects in group 2? So it's wanting to know if group 1 had a higher fever than the subjects in group 2. So group 1 is P1, group 2 is P2. But if the question were to ask it other way, did group 2 have experience a higher fever than group 1, then you would know that it would be the other way around. You could put it as P1 is less than P2 because P2 is okay. I think that was another thing we were trying to pick apart the sentences so we know how to basically reading comprehension so we can understand the question better, because that was one of our struggles as well. Okay. And then I guess that just answered my other question. So we figured this was correct, but P1 goes with X1 and N1, P2 goes with X2 and N2. And then the conditions, are the conditions gonna just be, they're not required, but they're gonna be like extra credit, right? It's never gonna be something for all of these sections. It's gonna be basically, if you know it, that's gonna be extra credit.
That's right.
But it's something that we should know if we want the extra credit. Okay.
Yeah.
We were also trying to figure out like what the parameters would be. That was kind of something that we tried to figure out.
Oh yeah.
So on this one, how would you define the parameters?
Would you say where P1 and P2 are the proportion of people who experienced a fever or did not experience a fever?
You wouldn't say did not experience fever, you would say who experienced the fever. Because that's what it's talking about. It is only talking about experience of fever, right? It says it right there. It says
experience fever as a side effect.
Yeah, after the second dose, 110 of 685 subjects in the experimental group experienced fever as a side effect. And then whatever for the other control group experienced fever as a side effect. They're giving you the proportions that experienced a fever as a side effect for group 1 and group 2. So yeah, so then P1 and P2 are the proportion of people that experienced a side effect. Well, hold on. Let's be careful here. I don't want to say P1 and P2 refer to that sample. Because remember, P1 and P2 are the population parameters. So I want to say that they are the proportion that experience a side effect in the populations of group 1 and group 2. You know what I mean? I just don't want you to say that I don't want you to refer to those samples of 685 subjects or 566 subjects, because P1 and P2 don't stand for that, the proportion for those samples. They stand for the proportion for what? For everyone? What do you mean everyone? What do I mean by everyone?
The population.
The population. So it's kind of hard to explain, but it's the population of all people who would take vaccine 1 or vaccine 2. Are there 2 vaccines or what? Yeah, there's 2 vaccines, right?
So are you saying that when you refer to P1 and P2, you're referring to everyone who took the vaccine is P1 and P2?
No, not took.
Oh.
You use past tense. You use past tense. Took, when you say everyone who took, you're referring to the 685 people.
Yeah, that's what I was trying to say. That's why you don't want to use P1 and P2, because that's not what this is saying. This is saying the 110 or the 67, because you're talking about who experienced the fever, right?
Oh no, you're even worse. You're
confused.
worse
Okay.
now. You're farther from the truth there.
Wait, so P1 and P2 are the proportion, right?
Population proportion. There's a difference between population and sample, right? P
But-
hat, there's something called P1 hat and P1. They're
So-
very different.
The population, P hat is the sample proportion.
Yeah, sample proportion.
But your notes say that we're inferring on two population proportions. So
Yeah.
what would the parameter say? Would it say they're the population proportion of people who experienced fever?
You can throw the word population in there to kind of like clarify that it's for the population. So that's a good idea, what you just said. Danny had a good idea, so that you can say where P1 is the population proportion that experience a fever as a side effect while taking vaccine 1. I'll say that again. Where P1 or let's talk about just P1 for a second. Where P1 is the I like what Danny just said, is the population proportion of people who experience fever as a side effect after taking vaccine 1.
And then P2 would be the same thing, but after taking vaccine 2.
2. Yeah.
So you have to separate them to get full credit?
Huh?
Do you have to like separate them to get full credit?
No, it's just more this is kind of complicated to say it all at once. You could say, this is kind of tough, but you could say where P1 and P2 are the population proportions that experience fever as a side effect after taking vaccine 1 and 2 respectively.
Oh, okay.
Oh, that's what. Okay,
Okay.
You can say it like that.
that's what we had.
Yeah. We were always putting like respectively.
Yeah, I like
So-
that way, but I was just struggling with like constructing it because you kind of have to. You inserted the word population, which helped.
Mm-hmm.
Because that makes sense that it's not talking about those samples; it's talking about everyone, right?
Mm-hmm. But then when you say like with
Right.
respectively, that's indicating that like you sampled.
Yeah.
You sample.
Wait, no. Say that again.
Like I'm saying, like when you say like with men and women respectively, or with Kim and Maggie respectively, that's indicating that like that was your sample. Those were
No,
your
that's not true. No, that's just indicating when you say respectively, it just says that vaccine 1 goes with P1 and vaccine 2 goes with P2.
Oh, okay. Oh, I see. Like that's your characteristic. It's like your variable, right?
It's just kind of an ordering thing.
I don't know.
When you say respectively, it's an ordering thing. Because if I say something like California, Nevada, like if I say this, how about this? The scores were 92, 98, and 100 for Joshua, Maggie, and Mario respectively. You see what I said? Respectively?
Mm-hmm.
I'll say that again. The scores were 92, 98, and 100
So
for
that
Joshua, Maggie, and Mario respectively. I'm just saying that
first score, Maggie got
that they're ordered. Yeah, they're ordered, right?
Yeah,
to each
okay,
other.
I see.
Yeah.
P1 is woman, you say with woman and men respectively, if P2 is men.
Exactly.
Okay.
Yeah.
So we were looking at the notes. So would this be okay? Where P1 and we're talking about the COVID patients. So where P1 and P2 are the proportion of people with COVID-19 for men and women respectively.
That sounds good. Say that again.
If you look where P1 and P2 are the proportion of people with COVID-19 for men and women respectively.
And I would do what Danny said, and I would add the word population proportion.
Population proportion.
I would always throw the word in population just so that to make it clear that you are talking about the population and not those samples.
And then
Okay.
just to clarify, we use another example from chapter 12 when it was talking about the mean.
Okay.
Or it was like mu1 is equal to mu2, mu1.
Are you sure it was chapter 12?
Or wait, I think it was from your 12 notes. Anyways, I'll just, so we wrote where mu1 and mu2 are the mean differences. Oh, I don't know, this might have been from 11 too. But we just wrote are the mean differences from the bullseye, not from this sample, for all possible throws for Maggie and Kim respectively. Remember it was from class?
Oh, yeah.
Oh, that was 11.3. It was 11.3?
Yeah, that couldn't have been 12 because it's talking about the means. Chapter 12
Yeah.
is talking about independence. So it's not about the means and proportions. It's about independence. But I don't know, do you want to focus on that now or you want to focus on something else?
No, I'm good. Yeah, I kind of understand now. As long as you say that's right, like, you can move on.
All right, does
Do you have
anybody
any
want...
questions from 11? One?
Number 8. Oh, we talked about tying this all in together.
Okay.
When it comes to interpreting the p-value. So when you put this all together and you get your test statistic and you get your p-value, this question right here, you're interpreting the p-value. So all you're really doing is when you talk about it being equal, because the p-value is low, so you would, if the p-value is low, you would reject the null. The p-value is low. So that's when you say equal, you're referring to this. They're just trying to tie the question together. So then you're agreeing to this. That's why you're saying equal.
No,
one would
no. Your logic is off big time there.
Okay.
It has nothing to do with the p-value. That when you write equal there, that has nothing to do with the p-value. That is always equal because we always assume that the null hypothesis is true. That's why says equal.
Yeah, that's what I'm. So where does this equal? Isn't this equal talking about this? That's what I'm trying to say.
Yeah, but you were mentioning the reasoning for that being that the p-value is low. It has nothing to do with the p-value being low.
Oh no, I meant interpreting the p-value. I would just saying that this right here, because the p-value is low, you're rejecting the null.
What? But that has nothing.
I'm confused. Okay.
But it has nothing to do with interpreting the p-value. That's what I'm trying to make sure you know.
I remember the question.
Okay, you go.
Remember, okay, so see how it's a two-tailed and it's not like greater than or less than?
Yeah.
So when interpreting the p-value, it said one would expect a sample difference proportion greater than the absolute value. And I remember asking you that last class, but I forgot if you clear it, Maggie said that if your differences are
positive or negative,
that
it's either greater or less than positive or negative.
Yeah. Can you because I couldn't figure out how we figure out. I know absolute value is if it's two-tailed, but I don't know when to say greater than or less than.
Yeah. Absolute value if it's two-tailed, and then if the test statistic is positive, say greater. If it's negative, say less than, or say smaller.
That's
if
it.
The test statistic is positive or negative. Yeah.
Okay, but also on MyMathLab, sometimes I would get a negative number, but it would say that I was wrong, and it'd say that I was supposed to make it positive.
The test statistic, or what?
Yeah, that happened to me once.
But that has nothing to do with this. That has to do with the test statistic, something that you're plugging it in a little bit differently. That's a different issue, maybe.
Okay.
If you're getting a positive test statistic and it should be negative, and that's a slightly different issue here.
Mm-hmm.
This interpreting the p-value part, I'm not going to ask this on this test, but for your homework, you should know if the test statistic is positive, then say greater than the absolute value of. If the test statistic is negative, you can say, let's see, smaller. Well, let me think.
So less than is negative numbers, no, negative test statistic.
Yeah, I don't know. Don't worry about this question much, but I'm thinking that if the test statistic is negative, you would put smaller than the absolute value of, but I'm not sure actually. That's why I don't even want you guys to worry about that question, you know?
Yeah.
So don't really worry about interpreting the p-val.
Not for the test, not for this test. The last test we did, but not for these tests, because it's
Can it be
not for
extra
tests.
credit? I'm just
Huh?
kidding. I'm kidding. I said extra credit, but like it's.
oh yeah, yeah,
So not for test 4, but for the final, basically.
yeah for the final because we did it on test 3, right?
Okay.
Oh, but I told you not to do it on this test.
Okay, great. Perfect.
Don't worry about the interpreting the p-value or interpreting the type 1 error for this test. Only for the last test.
So you would only want us to state the conclusion then?
Correct.
Okay.
As far as the test goes, yeah.
Emo, I had a quick homework question. Me and Ali were stuck on this, but he is at work right now, so he couldn't come.
All right, you want to share it? Okay.
Like, we didn't know what to do because we looked at the notes and there wasn't, because like with the notes, it was more like data, like it was information on a table already, and this one is kind of like different.
Okay, so it was data and this is statistics, right?
Yeah.
Good, yeah, good. So, and you're talking about how do you find the p-value? You want to focus on the p-value, right?
Yeah.
All right, so when you, man, this question, I don't like this one, but we can just do it. It defines mu d as hinderer minus helper. Do you guys see that? It says let mu d equal hinderer minus helper. Can you see it?
Yeah, this right here.
Yeah, so you guys see that? Good. Just wanted to point that out to everybody. Now, also notice that the alternative hypothesis is mu d greater than 0.
Yeah.
You have the correct answer, D. So basically, if mu d is greater than 0, then so you just basically got to get the differences. The mean of how long the baby watches the hinderer minus the helper is positive. So what does that mean? Hinderer minus helper. I don't like this example because it's kind of confusing to think about.
Yeah,
but
it's like really confusing.
does that mean that he's? So I'm thinking correctly. The baby is watching
Hinder longer than
the hinderer longer than the helper, right?
Yeah.
Okay, so he's mad probably. The baby's mad. That's why he's watching it longer, right? I don't know. I'm just thinking. The hinderer toy, he's like mad, so the kid's watching that. I didn't really read the question, but I'm just guessing on that. But that's a little bit besides the point. So look at the two numbers. We have statistics this time. The real issue is the fact that in this problem, we don't have the data, which is what you're used to. In this question, it gives you the mean. Where's the mean? Is the 1.26 the mean? Yeah, right? The mean difference in time spent watching the climber.
6.
So that's the mean difference. Hinderer minus helper. 1.2 seconds longer on average. And then standard deviation of 1.56. So that's it. So go to t-test and plug in 1.26 for the mean and 1.56 for the standard deviation, right? And that's it.
So t-test, I'm writing this down for Ollie as well. T-test and
t-test.
Input standard deviation and mean.
Yeah.
And then where do we input it in? Because I don't know if you can see it, but where do I put that in, like to the calculator? Do I have to put this in like a list or something?
No, you go to data. You know what? I wonder if I should. Should I project this to show you or no?
Yeah, I can stop sharing.
Here, let me show you this real quick. So how do we plug this into a calculator is the question. So we go here, stat, test, t-test, and then we go to data. So now it's in, no, we actually want it in stats, right? See how it's in stats?
Yeah.
So then I'm just gonna plug in 0 for mu0.
And then
what was the average? X bar?
1.26, and then standard deviation 1.56.
And what was the sample size?
I think it was greater than. Let me check. Yeah, greater than.
Sample size N.
Oh, 15.
15. And then greater than. Okay, so that's it. That's what you plug in.
Yeah, because we thought like we had to figure out data instead of using like stats. We didn't like think of stats.
Yeah, stats. Yep. Just plug in stats.
Okay. Thank you.
You're welcome. Anybody else want to share a question? Sharing is caring. Sharing is caring, everybody. Last time I checked. You can ask Mark about that mostly.
Sorry, can you
I
repeat-
did, but I
please
lost
repeat that?
my calculator.
What?
Can you please repeat that?
I said sharing is caring. You could ask Mark about that.
No, I mean the
Oh,
t-test. You go to stats, test,
stat
t-test.
test. Oh, stat test, t-test, and then just plug in the data if you go to stats. So once again, I mean, it'll be on the video, but stat, test, t-test, stat, test, t-test, and then stats.
Like this.
It's hard to see.
You have to go over to stat. You're on data.
Okay.
Thanks, Danny.
Press that.
Yeah. Then you plug in your mean and your standard deviation.
Yeah, plug in the mean, standard deviation, sample size, 0 for mu0, and then greater than for the alternative. And you can watch this video too, because I'm going to post this video. I'm going to try to edit it today or tomorrow. We'll see.
And then what next? After I put this in.
Danny, what next?
Oh, calculate. Go down to calculate on the bottom and then click enter. And it will give you your TO, which is your test statistic, and your p-val, which is the one right below it.
That's the same thing as enter.
Yeah, once you're on calculate, enter.
Like this.
I think so. I think. It's kind of blurry. Yeah, so see how it says T? T
Yeah.
equals, that's your test statistic. And then the P right below it is your p-value.
Oh, I see now.
So that's always how you find it for when you're given the mean and standard deviation.
It was from 12.2. It's just finding the expected by hand.
Okay.
I like understand it. I just want to maybe like go through another example just to make sure.
Pull up an example. Do you have one? And I'll show you how to do it. Pull up a question in the homework, and then I'll have you find the expected
okay.
by head.
Yeah, I'll pull a question up from the homework then. Because that was the one part that you said we'd have to do by hand, right?
Yeah.
Okay. Okay. Is it showing?
Wow, that's like the one we did in class, huh?
Yeah. I'll pick another one.
Oh, that's fine, but yeah, you can try this one.
Okay.
This one's cool. All right, so look, we're trying to see if there is an association between education level and what's that thing on the top? Health level?
I guess.
Yeah, health level, right?
Yeah.
So what does that mean? That if there was an association between health level and education level, maybe healthier people do better in school? In fact, if you look at the data in the excellent health first column, what's it say? It seems to defy all logic because there's more people that have excellent health that don't go high to a high education level. Like the bachelor's degree or higher is only 74, but not a high school graduate is 105. So more people don't have a higher degree who have excellent health. But then when you look at poor health, it's kind of flat. It's sort of uniform.
Mm-hmm.
As far as like the degree attained, I think, is that the highest level of their degree, level of education? Yeah.
Yeah.
So for poor health people, it's equally spread out, but for excellent health people, less of them have higher degrees. So
Right.
I'm trying to just see if there's any trends in the data. You know, that's all I'm doing. I'm like, I wonder if we're going to reject the null hypothesis and say that there is an association between health level and education level, right?
Mm-hmm.
All right, but you wanted to focus on trying to find the expected value by hand. Let's do that. So let's go ahead and find one of them by hand. Which one do you want to find by hand? Excellence, bachelor's degree or higher? Let's do that. Excellent and bachelor's degree or higher. So how would we find that by hand?
So you would first have to tally up the sum of all excellent, right?
Yep. Yeah.
Okay. And then you would
So
want...
can somebody get that? Is there any way to write on the screen? Oh shoot, you know what? Oh, I got this new tablet. I might be able to write on the screen now. So what do we get? Tell me what we get for this number down here. Below excellent.
62.
62? And what do we get? What else do we get for to the right of, how about bachelor's degree? What's the sum for bachelor's degree? If you add those up, what do you get?
414.
414? Okay, I can type. This is something. This is something. Hey, what happened? Okay. Unfortunately, we need the sum of all sum, like total sum. What's the total sum of all the numbers?
Okay.
Does it say? It's 1737. 1737 equals total, right?
Yes.
That was given, right?
Yeah.
So what do you guys think we do? How do we find the expected value? The one that we're interested in, how do I highlight? Any way to highlight? Let me see if I can highlight this. Nah. How about this? Oh, look at that. I can highlight. Well, you look at that. So this is the one we want to find the oops, that was 2. Okay, the 74, we want to find the expected value of the 74, right?
Right.
Excellent health and bachelor's degree or higher. Can somebody tell me how to get this?
So would you do 414 divided by 1737?
Yes.
And then
would.
you get a decimal.
Yes.
Is point, if you round it, it would be 0.24. And then do you multiply it by 74?
Yeah, so you get that value, whatever that is, and then you have to multiply this times, what'd you say?
So the
360.
decimal is...
Oh, don't use decimals. Get the exact answer. Just multiply the fraction times 362. and that'll give you the exact accurate answer for the expected value there. So really it turns out to be, yeah, whatever that is. That's the
So
expected value.
414 divided by 1737 times, what was it, 74?
362.
Oh.
What do you get?
86.28 if you round it.
Okay, that's how you find the expected value by hand.
Oh, okay. I thought you would always multiply it by like the value in here, like the 74, but
Never.
it's 362.
Yeah, because you're trying to, basically what this is saying is what? Understand what this is doing. 414 out of 414 divided by 1737 is giving you the percentage of people that have a bachelor's degree or higher, right?
Right, yeah, okay.
So let's say it's like 25%.
Right,
So 25% of everyone has a bachelor's degree or higher.
okay.
And what we want to do is say, if it's 25% for everyone, then it should be 25% for people of excellent health.
Mm-hmm.
How many people have excellent health? 362.
Okay.
You should take 25% of 362.
I see. That makes sense.
Yeah.
Okay. Yeah, so that makes sense.
Yeah. Good question. I didn't know I can write on someone's screen like this. Let's see. Can I increase? Oh wait, you know what? Can I increase the font? No. What is all this stuff? I can't wait to use my Wacom tablet. Wish I knew how to set it up now, but. So yeah, do you guys want to practice that again? Do you guys want to do another one on this example like that, or what do you guys want to do?
Yeah, can we do another example like that?
Yeah.
All right, how about this? Why don't you guys find this one then? The 70. Find the expected value for 70. In other words, I want you also to write down what you did in words. For instance, we expect 86.28 people of excellent health to have a bachelor. You want to understand, bachelor degree or higher. You see that? You see that sentence? So I want you to be able to write that sentence. You don't see it?
Sentence.
It's not showing up.
All right. How about
There
now?
it is. Yeah.
Okay. So you see that sentence? I need you to be able to understand how to come up with that sentence. Pretty much, I kind of give that to you when I write the question. I'm kind of gonna have to give you that sentence, kind of. I'm gonna have to say, find the expected number of, like right now, what's the sentence? Somebody tell me the sentence. So if it was a question, how would I write the question? I would say, find what? Find the
percent of people who have, or find the number of people who have a bachelor degree or higher.
for the 70?
Oh.
Would you say find the expected value of people who are in excellent health and have a bachelor's?
Not expected value. Find the expected what?
Number of people?
Number of people. Find the expected number of people. What? People what?
You're a high school graduate and have fair health.
Who are high school graduates and have fair health. Great job, great job. There it is. Find the expected number of people who are high school graduates and have fair health, right? So go ahead and find that. You guys done?
Yes.
All right, so tell me how you wrote your answer. Pretend it's a test and you need to show your work. So I'm gonna write down what you tell me to write down. What should I write?
So first I showed my work, and I found that there were 434 high school graduates.
Okay.
And divided that by the total of 1737.
Okay, and then what?
And then multiplied it by the total number of high school graduates. Oh no, of Fair Health.
Okay, which was?
271.
271?
Yes.
Which equaled what?
67.71 people are expected to have fair health with high school degrees.
Yeah, are expected to have. So you gave a sentence. So what'd you say? 67.71 people of fair health are expected to what?
Are expected to be high school graduates.
I would probably say
I kind of worded that funny.
expected to have highest degree high school graduate. I don't know. I'd probably write something like that. Because all of those people have a high school degree. So I would say, is it that their highest,
right? Okay.
Have highest degree high school graduate or highest level, right?
So we have to be specific like that.
Yeah, because all of them have a high school degree. Even if you have a bachelor's degree or higher, you have a high school degree, right?
Yeah.
Wait, I have a question.
Sure.
So the wording in the previous one, you said of excellent health to have, oh wait. I'm confused on like, should we divide the number of people who have excellent health divided by the total, or should we divide the number of people who have bachelor degrees divided by the total and then divide that by the excellent? You know what I mean? Like,
you kind of go both ways, actually.
Really?
You can use the row sum and then divide it by the grand total and then multiply by the column. Or, you know what I mean? You could do it either way, actually. You get the same answer because you can multiply both ways.
Oh, okay.
Did she do it differently this time than I did it last time? Is that why you asked that?
No, I think I did it. I was about to do it differently, so I was like, just making sure. And then I think you did it differently before. I don't remember, even though it was like 2 seconds ago.
Yeah.
But it's okay.
Okay. 2 seconds is a long time. No, I'm just kidding.
Not 2, but like I don't know. We did it like a minute ago.
Woo-hoo! All right. So what's up? What's next? You guys, does that help? You want to do more of these?
Yeah, that definitely helped because I was always getting it confused and multiplying it by just like this single number, like bachelor degrees who had excellent
Never
health.
just a single cell. It's always like a column total or a row total, right?
Yeah. Oh, also this is like a little detail, but when we're rounding, do you want it to be to like 2 decimals or is there like a standard?
When you're rounding, do I want it to be 2 decimals? The heck? How do I, hold on.
Yeah, the final.
Yeah, expected values, you can round to 2 decimals. It's a good idea. That we've kind of been doing that.
Right, okay.
Yeah.
Or would you like specify that on the test?
Probably not.
Okay.
But I'm not sure. But look out for the directions. If I do, then just kind of go with it. Go with the flow.
Okay.
Oh, Brian Robles said, how would you calculate the test statistic for a question like this? You guys, should we do that? You guys want to do that?
Yeah.
All right, let's try that.
Yes.
All right, let's do this question. Let's finish this. Let me get rid of all this stuff first. Let me
Do you
erase
want
all
me
this.
to exit out of my screen share?
Nah, because we gotta we need this test. We need this question, right?
Okay, right.
We need to see this question. So For Brian Robles. This one's for you, man. This one's going out to my boy, Brian Robles. All right, look. Now look at the null and alternative. The null says level of education and health are independent. They have nothing to do with each other. The alternative hypothesis, level of education and health are dependent. They have everything to do with each other. One affects the other. Calculate the test statistic. How do you calculate the test statistic in p-value? Anybody want to explain to America?
For 12.2,
Wouldn't you use the matrix? So you put that data into the matrix.
Yep.
So you go onto second matrix, you edit, and then for the dimensions, since there's 1, 2, 3, 4 rows that specify like the specific education, you do 4 by 4 rows that also specify whether the education was excellent, good, or fair. So on the matrix, you do 4 by 4, and then you input that data into your matrix.
I got an idea. I'm gonna have to do something crazy here. I'm gonna do something crazy. You guys are all good, man. You're explaining that well, but I need to I'm gonna show it on the calculator. So watch. Copy. How would I do this? I'm gonna show you how to do this on the calculator. Something crazy. Paste. I need to paste this onto my iPad. How could I do this well? First, I need to connect somehow. Are you guys seeing my screen or no?
no.
Can you disconnect?
Yes.
Are you seeing my screen now? No, right?
I
Not
just
yet.
see you.
Darn it, hold on. Zoom quit, don't send. Do I need to really do this again? Okay, good. I don't need to re-enter the ID. Come on, work. Please work. All right, now you see my screen. Good. All right, look. I copied the question, but I wanted to demonstrate how to do this on a calculator. So you got all this. We don't care about that. We care about the numbers, right? As Maggie and Kimberly were saying, you need to use a matrix. And what size matrix do we need? We're going to use a matrix with rows and columns equal to what?
4 by 4.
4 by 4, right? There are 4 rows. 1, 2, 3, and 4 rows, and then 1, 2, 3, and 4 columns. 4 rows and 4 columns. So you go to second matrix, and then where do I go?
Edit.
Edit, and then what?
And then you would enter in the 4 by 4 dimensions
Where?
at the top.
Okay, so
in
at
A.
the top, in A.
Yeah.
So go to A, then put 4 by 4 at the top in rows and columns.
Yep.
And then plug in the matrix, right? 105, 179, 79, 121, 115, 134, then what? 70, then what?
115.
Okay,
And then 68,
okay,
174,
okay,
53,
okay,
110,
okay,
and then 74,
okay,
155,
yep,
69,
yeah.
and 116.
All right, good. So far, so good, Brian.
Array A again?
Say that again.
How did we find array A again? Like how
Went
did we...
to second matrix. Show you again. Second matrix. Matrix is right here. See that right there where my arrow is pointing?
Yeah.
So second matrix. So I'm gonna go second, and I'm gonna hit that matrix, and then I have to go to edits, as Maggie explained, and then you click A, and then you could input all the data there. We have completed our matrix. Okay, now what should I do?
You would go to chi-square test.
Okay, so how do I do that?
So stat.
That,
Go to tests,
test,
and then scroll down to chi-squared test.
okay, right here.
And then you would enter observed A, and then it automatically gives expected as B. And then
That's right. So observed, I already have it in. It's in A. And then expected, like Maggie was saying, the calculator is going to give those values. We don't need to input them. And look, we have our chi-squared our chi-squared test statistic. We can write that down. So chi-squared sub-0 equals to what? 23.10. And then p-value equals to, by the way, these are approximate. We're rounding. So 0.00 what? 59 or 6? Let's go with 006. That's it, Brian. There you go, bro. Bro to chip, as they say. Bro to chip. You guys ever heard that?
no.
No. I'm sorry, how do you get that again? I got a completely different answer.
How did I get those values?
Mm-hmm.
What did you get, by the way?
For p squared, I got 0.4001.
Say that again. 4.001
No, 0.4001.
for chi-squared.
P squared.
Watch the video, bro, because I'm gonna post this. I'm gonna post this after. You can just watch the video slowly because we showed it on the screen, right?
Right.
So all you gotta do is watch the video. I'm gonna send this tonight or tomorrow. You have all weekend to study it, because that way we can do more problems.
Okay.
Yeah. You can just pause the recording and stuff like that. You go however fast you want. So what's next?
I think you already did this too, but I also had a question for getting the p-value for section 11.3 when you use two sample t-tests.
Okay. Do you have a question? You want to pull it up?
Yeah.
Hold on. Let me see. Let me stop sharing real quick. Oh, I gotta go down here. Hold on. Stop. Okay. Oh, you know, I should have checked if I can use this thing. This Wacom tablet. How does it work?
It was this one.
All right.
So for me, I don't know why it doesn't come out in the calculator because I go to stat test, two sample t-test.
Okay.
But when I was looking at your notes, like this doesn't come out for me on my screen. I don't know why. Like this right here.
Zoom in on that real quick. Do you see how it says list?
Yeah.
That's because you see how data is chosen?
Yeah.
Well, in the question that you just showed me, you need to input the stats, right? Because there is no data.
Yeah,
There's
so
only
we just get, so we would use stats, right?
Yeah.
Okay, because I was going based off of this and using data, but I didn't realize that you had data here. And then this one was like asking for stats. So all
This
of
one's
these, yeah. So all of these homework questions ask for like stats, basically. Then,
they do?
like most of them do, because even for like the previous one,
Do you want to do one of them? That one has data.
no, I think it was this one. Yeah, it was this one.
So that one has stats, right? Statistics. So yeah. Which one do you want to work on? Pick one.
We can do the other one, I think. This one.
All right, let's try this one. Let's see. I kind of want to demonstrate on my calculator because I'm so cool. Hold on. How do I?
I could stop sharing.
I know, but let me take a picture of this first. Okay, I got it. So all you want to know is how to find the test statistic and p-value, right?
Yeah.
Okay, let me show you. So we're doing technology here. All right. So I got that copied. So you can stop sharing now. Demonstrating technology. Sample mean. And then what else do we have? Sample standard deviation. Do we have n? We also have n, right?
Yeah.
So we have 3 bits of information for community college and no transfer. Community college with the transfer and then no transfer. Okay, we gotta plug that data in then. So look, I'm gonna show you guys how to find the. Well, what if I didn't know? What if I did not know what test to do here? And I was like, what do I do here? Well, I have sample means. So this is actually x1 bar. This is n1, right? This is n2. This is x2 bar. This is sx1, sx2. You see that?
Yeah.
So I'm like, oh, I gotta be doing a 2-sample t-test. I have to be. There's no other possibility. This has to be a 2-sample t-test. I have to be comparing a null hypothesis mu1 equals mu2. I have to be. Based off of looking at that, you see that?
Yeah.
I have to be comparing 2 different means with independent samples. Independent samples, right? Because of how the data was given to us. That's what it has to be. So, okay. I'm dying to use my Wacom tablet. Can't do it now because I'm on my iPad. All right, so would anybody like to tell me how to plug this data in?
So you would go to test 2-sample t-test.
Test? Wait. Stat, you mean?
Yeah, stat test.
Stat? Let's go slow because there's a video.
Okay.
Test, then what?
Then you go to 2-sample t-test.
2-sample t-tests.
And you
Then
put
what?
stats. So because we have a sample mean, standard deviation, and an n.
Yep.
So then in x1 you put your sample mean for community college transfer, which is 5.36.
5.36. Enter. Now what?
Standard deviation 1.153.
Okay, enter. Now what?
N1 257.
257. Enter. Okay.
X2 4.29.
4.29. Enter.
And then standard deviation for the second one is 1.002.
Okay, enter. Then what?
And then your final sample size is 1,189.
Enter. Okay. Anything else I should think about?
And then it's asking you if the sample is greater than, less than, or not equal to, and it's greater than.
I don't remember. What does the question say? Because I didn't get the alternative. But I'm gonna know. Now guess what? I don't even need you to tell me the alternative. There's only two possibilities. So here's the question. There's only two things that it could be. Tell me what it can't be out of those three. Out of the not equal to, the less than, and the greater than. Tell me which one that it definitely cannot be.
It can be not equal to.
Let's see. If I click not equal to, nope. It can be not equal to. It could be a two-tailed test.
Because the question is saying one aspect of his research was to determine whether students who first attended community college took longer, so it has to be greater than.
Took longer, right? Now, but my question, you still haven't thought about my question. I'm asking the question because I'm trying to make a point. Anybody see the point or no? My question, once again, is which one can it not be? It can be two of them, but it cannot be one of them.
Right-tailed?
Let's try right-tailed. No, it can be right-tailed. Want me to try left-tailed?
Yeah.
All right, I'm gonna try left-tailed. What do you see?
Oh.
Do you see what I see? On my screen? Do you see
Yeah.
or no? Do you get the point?
Can you put not equal to it again, so I can?
And not equal to, there you go.
So it doesn't stay like within that like curve. Is that what it is? Like all that data is in the mountain.
Look at the p-value. Look at the p-values. Okay, not equal to, check the p-value out. The p-value is very low, right? The p-value is very low. You see it?
Yes. Yeah.
I'm gonna put less than. What's the p-value now?
Oh, it's 1.
Does 1, is that normal?
No, it can't be 1.
It's very abnormal. That's what I'm trying to point out to you. To look at active. I don't know what's going on. Like,
So
what?
will all of this be on the test on Monday?
Huh?
Will all of this be on the test on Monday?
Yeah. Chapter 11 and 12. Yeah.
Oh,
Talking about, yeah, Maggie.
So I just wanted to make sure. You said that we would be using the calculator to figure out, like the test statistics for everything, but then the only thing that we're like calculating by hand is expected value, right?
Correct. That's the only thing you got to find by hand. Yeah.
Okay, because I remember seeing in our notes a whole bunch of like big equations and like formulas to calculate it, but we don't have to use those.
Not the chi-squared test statistic. You don't need to find that by hand, because you know how it's the summation of O minus E squared divided by E?
Right.
You don't need that formula to find the test statistic by hand, because you can have you do it the easy way.
Okay.
And p-value, you do that the easy way. The only thing is, yeah, the expected value. That's it. So yeah, ignore that formula.
Okay. And then when we're saying the null and alternative for chi-square, would we say there's no association and there is an association, or would you say they're independent or they are dependent? Or is
Either
it
way, both of those are well. So
okay.
both of those are well. Both of those are well. Both of those are well. Both of those are magnifico.
Okay.
You can say there is an association or there is not an association, or you could say the two variables are independent or the two variables are dependent, whichever language you want to use.
Okay. And are they only right-tailed tests for chi-square?
Yeah.
Okay.
Yeah. Starting from 0 and above in the first quadrant only, because the test statistic is only positive because you're squaring the differences.
Right. Okay.
Wait, is she saying that the alternative is always going to be... Wait.
No, she was saying,
I'm confused.
is the chi-squared distribution always positive, right?
Yeah.
There is no right-tailed, left-tailed, and two-tailed test in chapter 12.
Oh.
There's no longer any tail. There's no longer right-tailed, left-tailed, or two-tailed. Is that what you were saying, Maggie?
Yeah, that was kind of what I was trying to figure out. Like, is it?
So yeah, good job, Danny. You caught that. You caught that, Danny.
Always going to be positive then.
Yeah, but it's not a right-tailed, left-tailed, or two-tailed scenario anymore because it's independence. It's words now. It's words. It's
right. I was looking at the graph on your calculator and it just made me think of that, but it's different.
Yeah. So I was gonna ask that question too. But so for 12.2, basically you're just gonna state the two things, like say category Y and category X, and then you're gonna say are dependent for like the null, or are independent for the null, and then for the alternative, they're not independent when you're stating the null and alternative hypothesis.
Yeah, but you don't say not. But you don't say not independent. You say dependent.
Oh, okay.
Dependent.
So independent and dependent. That's it.
Right.
Independent, dependent. Okay.
Right. Or associated or not associated, as Maggie said.
Okay.
According to the p-value, if it's less or higher than blah, blah,
yeah. Yeah.
Okay, then for the HO, for the null and the alternative, like when we're writing it out, because like I always think of like right-tailed as like non-equal, and right-tailed as like less than, you know, and greater, like those symbols for the alternative when we're writing H1.
Yeah.
So
say that again.
So so you wrote your HO, but for H1, like it can it still be like not equal to, less than, or greater than?
For this section, yes. This is 11 point, I don't know, 11.2 or something. This is 11.2 or 11.3. I forgot what section it is. But this is chapter 11. So yes, this is chapter 11, right?
Oh, No, but Maggie was talking about the chi-squared, which is 12.2.
Yeah.
So
Yeah, so the point is,
the
the point is that in
11 now.
chapter 12, the point is that in chapter 12 there are no mu's or p's. There's no equals and greater thans or less thans. You understand that?
yeah.
There's no right-tailed, left-tailed, or two-tailed anymore in chapter 12.
Okay.
It's only one thing: independent and dependent. That's it. The null is independent. The alternative is dependent. That's it.
Mm-hmm.
I have another question, actually, going back to 11.2.
Okay.
Going through notes that I had. I forget which homework question it was, but we had to find the critical value, and that was where you told us to use inverse t. Is that going to be something that you want us to show on the test? Like, is that going to
Critical values? No, critical values is not on the test at all.
Oh, okay.
Yeah.
It was in the homework, so that kind of
Yeah.
confused me.
Yeah, it's in the homework, but it's not on the test.
This is what we mean by homework looks different than the test.
Yeah.
Yeah, but I've mentioned that like 100 times.
Yeah,
That's not on the test.
we thought you did, but we just wanted to double check to be like.
Yeah.
I have a question. So when we were going through 11.1, we came across the question, and this is what it said, and this is how we determined whether it was greater than, less than, or not equal to for the alternative hypothesis. And it was, are you a total abstainer from, or do you on occasion consume alcoholic beverages? So when there's like those yes or no questions, that's how you're going to determine, because it's not really stating, greater than or less than.
You want to show the question? Because I don't know what you're talking about.
Yeah. Let me find it really quick.
All right.
Almost there.
Okay.
Okay, here you go. Okay. So this question right here, how it says, God, you can't, this picture's on the way. All right, so in 1947, an organization surveyed 1,100 adults and asked, are you a total abstainer from, or do you on occasion consume alcoholic beverages? Of the 1,100 adults surveyed, 385 indicated that they were total abstainers. In a recent survey, the same question was asked of 1,100 adults, and 319 indicated that they were total abstainers. So the first part wants you to write the null and alternative hypothesis. So if it's like a yes or no question, which is right here, that's going to be not equal to for the alternative hypothesis.
No.
We're trying to pick apart the question to figure it out. I mean, that's the answer, but
I think you're missing the point. I don't know what's it saying. Let me see. I don't think you're seeing it. Your yes or no question means it's two-tailed. I highly doubt that. By a quick scan, this one doesn't make any sense to me. I feel like it's missing a sentence. In 1947, an organization surveyed 1,100 adults and asked, this is in 1947, are you a total abstainer from, or do you on occasion consume alcoholic beverages? Of the 1,100 surveyed, 385 indicated that they were total abstainers. In a recent survey, the same question was asked of 1,100, and 319 said that they were total abstainers. Complete parts A and B below. Determine the null and alternative. Yeah, this question is bogus. It's missing information. There's nothing in there that tells you that it's a two-tailed test. I don't know what the heck is wrong with this question.
This is what I was talking about.
yeah, I know. I just realized that.
Ugh.
That's why I brought it up, because it was in the notes that we made.
I don't see anything in the question that says, it's like it's missing one sentence that should say something to help you to know if it's a right tail test, left tail test, or whatever.
Mm-hmm.
It's like it's missing something. I don't see. It doesn't say, is it different? Like, for instance, it should say, Have things changed? It should say something like, have things changed since 1947?
Yeah.
It says, what does it say? A recent survey asked the same question?
Yeah, because in 1940...
Do people today believe differently? Or do they have things changed? Do they have a different preference? Do more people like alcohol? Do less people like alcohol? It's missing something.
Oh, okay. So if it were to say, like, in the last part of the question, in a recent survey, the same question was asked of 1,100 adults, and 319 felt differently about it, and they do like alcohol. So that would be the different word, or that's the change in a sense.
Yeah, this question.
So that would make it. Okay.
Exactly. This question is bogus. It's like it's a bad question.
Okay. So don't worry about it being worded like this, because it won't be. Because when you're looking to determine what direction to go in, you're looking for like different, something like that, which is going to tell you. Okay.
How about have things changed today, right? Have things changed?
So it would be like, it could also say like 5 years later, things have changed, and 319 people like alcohol out of the 1,100 surveyed. That could be a two-tailed?
No, it would say, is there enough evidence to say that things have changed since 1947? It wouldn't say things have changed. It would say, have things changed? It's a question mark.
Is there enough evidence? Okay.
To show that things have changed since 1947.
Okay.
I feel like in a previous chapter, when we were talking about like keywords for right-tailed, two-tailed, or left-tailed, you said that if it said the same, like if 5 years later the results stayed the same, that would be a two-tailed.
Yeah, that's right. If it says are things the same, then it's also two-tailed. That's a good point. But this one does not say that.
But we were talking about that, and doesn't that sound kind of like wrong? Because if they were the same, they'd be equal, you know? But like two-tailed is saying not equal. Like I get it, but we just wanted to clarify because like it sounds wrong, you know? Because if they're the same, they're equal.
The same, and not the same are the same thing. It's the same thing, you know?
Yeah, sure.
If I say are we the same, or if I say are we different?
Like what?
The same and not the same are the same thing.
Yeah, they're the same thing.
All right, Professor.
You want to know why I say that they're the same thing? Because they're both testing equality. They're both testing equality. If I say, are we the same?
Okay,
or if I say, are we different?
Okay.
Same question.
That makes
sense.
More sense.
Okay.
Yeah.
Man, this stuff is weird.
It's like a foreign language.
Literally.
Right, it's like me saying, do we have the same amount of money, or do we have a different amount of money? I'm really addressing the same question, aren't I?
Yeah, just like different wording, huh?
Yeah.
Oh, okay.
Or do I say, do I have more money than you? Or do you have more money than me?
Mm-hmm.
So, right-tailed, left-tailed, or two-tailed?
Mm-hmm.
Right.
Okay, and then I had one more question on 11.2. I'm gonna stop and then start again, but it was something else that we went over. It has to do with the way a question's phrased that we were talking about. Let's see. 1.2. Okay, so not this one, but I believe it was this one. So for part C, is this how it's going to be worded? Like where it says test if mu-d is less than 0 at the alpha equals 0.05 level of significance, when it's asking you to determine the null and alternative hypothesis? Like, how would?
Not at all. Not at all. It's not going to be asked like that. That's another example of Danny, how this homework is not going to be like the test. Because the test will not look like that. Because this question has zero context.
So more like something like this.
Yes.
Okay.
A question that has zero context, it's going to look weird. It's going to look different to you because there's no context, right?
Okay. So something like this, where it's talking about the 17 babies and whether the hinder or the helper toy helps, and
Yeah. So in part
okay.
B, it says test if the difference in the amount of time the baby watched the hinderer toy versus the helper toy is greater than 0. See, it's a sentence. It's a sentence.
Okay.
In part B.
This question was so weird.
Yeah.
No, it's a weird question.
And then will it always tell you like to find the difference by doing like xi minus yi or like?
No, it will not say that.
Okay.
I mean,
what about?
I probably should have you do that to make everybody's answer the same. Because if I don't say
I
that,
mean, like, yes, if we're doing L.
what?
Sorry, I was just saying, like, so you don't want us guessing if we're doing L2 minus L1 or L1 minus L2.
Yeah.
Right. Yeah.
Yeah, like that. There was.
It's different.
Because
No,
otherwise,
it's not that I don't want you guessing. It's not that I don't want you guessing. It's that I don't want there to be multiple correct answers. You understand what I'm saying?
Yeah.
Because you could subtract one way and it'd be correct, and Maggie could subtract the other way and it could be correct if she does less than and you do greater than on the alternative. But I don't know how I'm going to do the test yet.
So like depending on the alternative, if you say it's like less than, then a negative number would be fine. But if you say it's more than, okay.
Yeah.
Oh.
Wait, say that again?
So if for the null hypothesis it's equal to 0, but then for the alternative, if you say mu d is less than 0, you can't have a positive number. But if you say it's less than 0 and you have a negative number, then it's okay, like the test statistic.
Got it.
Basically, go to your null and your alternative, and then go from there. Like.
So so I get what you're saying. So this number right here, the test statistic, if it's
has to be
a
greater
negative number, then it's going to be less than 0, the alternative. But if it's a positive number, then the alternative should be greater than. Is that what I'm right?
Yeah.
Is that correct? Yeah.
I wasn't even paying attention. Is it correct?
Okay, so
I think so, yeah.
When referring to the test statistic,
I was looking for a test because somebody said their test was missing. Sorry.
Oh, no.
I'm not just goofing off. I'm actually looking for some students' test because I'm trying to find the test. I don't see it, but okay, go again. What were you saying?
So the test statistic, if it is negative, the alternative hypothesis it is less than 0. But if it's a positive number, the alternative hypothesis should be greater than 0.
Correct. That is true.
Okay. Yeah, so we figured that out. Perfect.
Yeah. Yeah, that's a good.
Okay,
good
I'm gonna write this as a note really quick.
Great observation.
So your test statistic has to be. Wait. So if it's a negative number, then you're doing something wrong.
Well,
No.
depending on the alternative hypothesis.
Right. Okay. So basically, determining on your alternative, your test statistic must match your alternative. Like in terms. How would we write this?
Can you explain it? What you just said, Joshua?
So the test statistic, like how this test statistic right here is 2.69.
Mm-hmm.
So the alternative hypothesis, see how it's greater than 0? Because this number, the test statistic, is positive. So if this test statistic was negative 2.69, then you would choose E, because your alternative hypothesis would be less than 0.
Okay.
So if your test statistic is negative, your alternative is less than 0. If your test statistic is positive, your alternative hypothesis is greater than 0.
But that's for questions when they're not telling us what it is. Because
Well,
right,
you know-
it's telling us that hinder was spent more than helper. So that's how we know that the alternative is hinder is greater than helper. Because it tells us.
Yeah, if it tells you, yeah. This
Okay.
question tells you. Where does it tell you?
It tells you an A, remember? Remember it says look at the hinder toy longer than the helper toy. An A? Look an A.
Oh, yeah.
I feel like we went over this questions like many times.
We did. It's right here. It's longer than the helper toy. So that is what's telling you that the alternative is greater than, because it's longer than, yes. But I think the way that with the conversation, and correct me if I'm wrong, was that's kind of your way also of checking the alternative hypothesis is because you're going to get your test statistic, and your test statistic is going to verify that answer is actually correct or not correct, depending on what you put.
Yeah.
Yep.
Kind of like a double check in a sense.
Mm-hmm.
Yeah.
I have another question, or I wanted to ask something. So we went over this too. When it came to writing the conclusions to when you reject or not reject something. So when you say, like, let's say you're going to not reject the null hypothesis because there is not sufficient evidence. To conclude that sentence, you're just restating the alternative hypothesis.
Yeah.
That's okay. I was just trying to think of a way to like memorize that so it's not like so all over the place.
Yeah.
Cool.
That's right. Whenever you write your conclusion, when you say there's sufficient evidence to, you always just kind of say that alternative hypothesis.
Okay, and then vice versa, if there's whether there is or there is not sufficient evidence, you're restating the alternative hypothesis.
Exactly.
To conclude. Okay.
Yeah.
Cool.
The alternative, the non-technical conclusion is always about the alternative hypothesis.
Okay.
And the technical conclusion is always about the null hypothesis. So for instance, if you're in chapter 12, you would say there's insufficient evidence to conclude that level of education is dependent to health. See that?
Okay.
There's insufficient evidence to conclude that level of education and health are dependent. See, notice how I'm using the word dependent? Because that's the alternative hypothesis.
Because that's the alternative.
If I'm in 11.3, I'd say there's insufficient evidence to conclude that SMC students smoke more than or make more money than West LA college students. If I'm in 11.3, there's insufficient evidence to conclude that SMC students make more money than West LA college students. If I'm in 11.2, I'd say the same thing. There's insufficient evidence to conclude that Californians make more money than New Yorkers.
Okay.
If I'm in 11.1, I'd say there's insufficient evidence to conclude that the proportion of people in Italy with the coronavirus is greater than the proportion of people in Africa.
Or back to like the community college question, which was an 11.3 question. It was reject the null hypothesis because there is sufficient evidence that
that's very bad. What you just said is very bad.
There is sufficient evidence?
No. You just took the technical and non-technical conclusion and morphed them together. So can you say what you just said?
reject the null hypothesis because there is sufficient evidence?
And that is one of the most aggravating sentences that I see on a test.
Okay.
So can you just say that again so people don't make that?
Reject the null hypothesis because there is sufficient evidence?
That's
No.
It's on my
No,
mouth.
you reject it because the p-value is small.
Hence,
You reject it because of the p-value.
there is sufficient evidence.
You're combining the two conclusions into one. And what's worse is that you're using the beginning of the second conclusion as the evidence for the first conclusion.
Wait, I'm confused because I thought.
Now, wouldn't you say reject since p-value it can be less than or equal to the alpha level, and then you say there is sufficient evidence or there is not sufficient evidence?
Exactly.
Oh, okay. So the p-value first, and then continue to lead with there is sufficient or not sufficient evidence.
Yeah, because of the p-value. That's why there's
Because of the
sufficient
p-value.
evidence.
Got it. Okay.
Because you rejected the null hypothesis.
Okay.
So you would say, as your technical, you would say reject because the p-value is less than your level of significance.
Yeah.
And then your non-technical would say something like there is sufficient evidence to conclude that blah, 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 whatever you were saying in your hypothesis.
Yep.
Okay. That was one thing I struggled with on the last test. I kind of ran out of time, so I didn't say the whole conclusion.
Yeah.
I kind of did what Josh did and mixed them together.
Yeah. I know. I see that a lot. I'm just like, no. Whenever I see that, I'm like, no.
Sorry.
But with 10 O's. I'm like, no with 10 O's.
And some sad faces.
Yeah, same.
Head out.
All right, y'all. Well, good job.
Thank you.
Thank you.
Thank you.
All right, bye.
I have a request.